Cool. That's over there. I like it, so then I can just stay right there. Okay. By the way, my name is Jeff Waller. I teach in the math department. I could teach in the physics department if they would just offer me a job early enough in the semester, because normally I have my schedule set and they're like, could you teach us? Oh, no. I would love to teach physics again, but and I also work in the Math Study Center or Tutoring Center. I coordinate that along with the embedded tutors for the math program. So that's me, right? You guys, can I trouble somebody? Does anybody have just a blank sheet of paper that we can use for a sign-in sheet? Oh, I got it right here. Cool. And go ahead and just put like name and then class and then professor. That's what's important. Yeah. All right. Using this as sort of an outline of stuff. Just to let you know also, we are going to stop every now and again. There are some problems in here, and all the answers to all the problems are in the back. In case there's problems we don't get to and you want to try them later, the answers are back here. Okay. So let's start off with a request from somebody about decimals. So the specific problem you said was, what was it, 7.1 divided by?
21.
7.1 divided by 21?
Opposite.
Opposite. No. So what's the concern here? So you had to do it by hand, I guess, right? Okay. So how do you rewrite this to be more something you can use by hand? You would put 7.1 into 21, right? Mm-hmm. Okay. And what's interesting to me as a math teacher, I very often get students who come from other countries, and not every country does their division like this, which is interesting. So, for example, I had a Russian student. Every time I have a student, I got to get them to remind me, because it's not something I do all the time. But it's really kind of nifty. They do all the same work, they just kind of organize it differently. Okay. So, anybody know what to do about a decimal here?
Ignore it?
No?
I think we have to put at the final, when we get the result, we have to put the...
Oh, if there was a decimal in here, then I could ignore it and just worry about it at the end. But isn't this decimal up here? So I don't want there to be a decimal up here. I want this to be a nice whole number, right? You guys kind of with me? So this is kind of cool. What am I allowed to do to any fraction? I can multiply the top and bottom by the same thing, correct? Mm. So there's one number that would make this so good. What happens if I multiply anything by 10? Any decimal by 10? Do you guys know? The decimal just moves over. So if I multiply top and bottom by 10, this becomes 210 over 71. So that translates into this shortcut. Move this over, move this over. So I don't know if any of you guys remember doing that with long division. No?
And that would work out because 71 can't go into 21. That's another way to think about it, right?
Oh, well, 7.1 can, totally. Yeah, it's just going to be, decimals, they can get as small as they want to. But it's just, when I have a decimal here, it gets a little weird how to work with that. So, now what? So you think 7 goes into 21.3, but 3 is going to be too much, isn't it? Right? Because 3 times 71 will be 213, right? So if I try 3 times 7 is 21, 3 times 1 is 3, that's too much. So then I have to do 2. Is that cool so far?
Yeah.
Right. And then twice 7 is 14, twice 1 is 2. Yes?
And we choose 2, like why I choose 2 or 3? Why not choose like even number or?
The number should be less than what we have.
So yeah, if you try to say 3, there can't be 3 71s into 10 because 3 71s is 213, which is more than the number itself. Right? Okay.
Right.
So therefore it's got to be 2. Now there will be a decimal component, but we have to figure that out place by place. So then 2 times 71, 142.
Yes.
Right? 142 is 58 away from 200, so it's 68 away from 210. then I can bring down a 0. So here's the decimal, right? Right? And then you just kind of repeat. 71 times what is, so 7 goes into 68. How many times?
1. 1.
Well, more 7s than 1, right? 7 times what is close to 68?
Less than 1.
9.
9, right? Because what's 7 times 9?
63.
63. So yeah. So 9 times 7 is 63. Times 1 is 9. Subtract. So it depends on where they want you to end, right? Bring down to 0. 7.
The 0 is why we put 0. We always put 0.
All right. Well,
You have to
any
add
number,
0.
any number.
Mhm.
$4. Couldn't I write it like this? Can't I also write it like this? I could technically also write it like this. That still means 4,
Yeah.
right? Yes.
Where'd you bring down the 9 from?
You minus.
This?
Where'd
Wait.
you bring the 9 down from?
This?
Yeah.
9 times 71, 639.
Okay.
Yeah, just like 2 times 71 was 142.
So why'd you bring it down though on the
What did I, wait, okay, let me make sure I understand. Bring what down?
the 9 was 639? Where'd you bring that 9 from?
This here?
Yeah.
9 times 1 is 9.
Oh.
9 times 7 is 63. So 9 times 71 is 639,
Okay.
right? And that's where I got the 142, was twice 71 is 142. So 9 times 71 is 639.
Okay.
Subtract, bring the 0 down, right? How many zeros are here? How many zeros?
A lot.
There's an infinite number. I can keep going forever. Right? Which is why something like 1 divided by 3, do you guys know what 1 divided by 3 is? Somebody's got to.
Also times 10?
No.
No?
Just does somebody know what 1 divided by, what's 1/3? Do you guys know it's a decimal?
0.0.
No, it's 0.3333333 and forever. Remember that bar meant forever? Do you guys know that? No? Okay. If you don't know it, it's okay. I just wanted to see, sometimes a lot of people kind of know 1/3 is 0.3 forever. Yes?
So it's 639. Shouldn't it be a 510 instead of 410?
No, because it's 80 minus 30 would be 50,
Oh, okay.
but I'm subtracting more than 30, so it should be less than 50.
Okay.
Right?
And we start from left to right when do minus?
Left to right. No, well, no, I mean, so technically, I mean, if you want to see the full, you have to borrow 1 from this guy, right? 10 minus 9 is 1, 7 minus 3 is 4, right? And then you bring down.
Right
0.
to left.
Yeah, okay. All right. Okay. By the way, real quick, we used to teach like a math 90 and a math 110. It was like elementary algebra and intermediate algebra. So I don't know if you guys know that that's gone now.
Oh.
The math department did not want that. It was, the decision was made for us. So I don't know if any of you guys kind of missed that we used to offer those. I don't know. Because that
And now
certainly.
with the
I had
offer.
you last year, but I kinda like forgot it.
Gotcha.
At Southwestern.
Understood.
And what they do now?
Huh?
What they do now?
So now we put people into transfer level courses and with support courses. So it's a whole thing. I'm not gonna talk too much about that because I'll start go off on a rant and I get all depressed about. Anyway, I'll stop. Because it is kind of depressing to me. Anyway, is that better?
Yes.
Yes.
For example.
Okay. So, and then you would just keep going until they tell you to stop, right? They might say rounded to the 1000th place or something, so you'll know kind of where to stop.
Like now for 410,
Yes?
if we wanna complete.
So then 7 goes into 41. 7 times 6 is 42, which is too much. So I'll bet you it's 5.
Okay.
And then that'll be 5, 35. And then you subtract, and then you bring out 0. So now the algorithm it's just the same thing over and over. How long would that go for? Possibly forever, right? So at some point they got to tell you, oh wait, stop, it's okay, right? Or you'd be taping papers together for your homework, taping papers and bringing it, taping more paper. Good Lord, no, don't do that. Okay. Anything else related to this kind of thing here? Do a lot of you guys have to do stuff like this by hand? Yes? Okay. It's actually, that actually just speaks to my heart there. But, alright. So let me know if there's any more computational stuff you want to talk about, like that. Okay, so, let me see. So this we'll talk about, there's a whole section about unit conversions. I'll make sure that I include some dimensional analysis. If there's any more of this kind of stuff, just let me know. So we kind of start off, if you look at the little workbook kind of thing. All right, the very first thing we're talking about is just exponents. Just what do exponents mean? Because scientific notation, do you guys use scientific notation? Yes. So in order to understand scientific notation, we have to understand exponents, because that's a huge part of scientific notation. So for example, what does x cubed mean?
X time.
Yeah. Just like what I like to say, you remember what 3x means? That means x plus x plus x. So sometime in history, somebody is writing a bunch of x's and they're like, oh my god. So let's say they had 70 x's. Yes? They're like, oh my god. He's like, let me just run a 70 in front. There. Holy shit. Just that's 70 x's adding. Right? Is that running? Okay. A little too far over. Okay. You guys with me?
Yeah.
So then at the same time, on the other side of the world, somebody had x times x times x times, and it's like, oh man, I wanted to put 70 to mean times. So he's like, okay, where can I put the 70? I could put it here. That is weird. I can put it here. That's like a division. Let me just put it up there, right? So at some point in history, we had to make that shit up. And it's just shorthand, so we don't have to write all that stuff out forever. Does that make sense? So why do I tell you this? Because it's important for you to know. The way we defined it leads to all the properties. Hey. Uh-oh. Shoot. Okay. Sort of going through that, but also if there's other things you want to talk about, just let me know. So, fundamentally, exponents just keep track of how many multiplications I've got to do, right? So, if I had a problem like x to the 5th times x to the 7th,
We add.
say again?
We add.
You add them. Why does that make sense? Because this would be 5 x's in a row, right? And this would be 7 x's in a row. So how many x's in a row do I have now? 12. Is that cool? So that's why when you multiply like bases, you add the powers, because you're just collecting. So this guy has 5 x's to multiply. This guy brings 7 more x's to multiply. So of course they got 12 x's to multiply. Okay, maybe? Okay, I like it. So what about if I had this?
Probably minus.
Yeah, because this would be, why do I keep picking? Alright, I think that's good. How many x's would cancel? 3 would cancel, right? 1, 2, 3 cancel. How many's left? 6. So don't do this, right? That's just a momentary thing, just to show you. So the shortcut is 9 minus 3. Why does that make sense? Because I had 9 x's to multiply. Somebody divided 3 of them away, so of course I just have 6 left to multiply. So far, so good. So, what about this?
X by itself.
No. I mean, what's one way to look at this? How many x's do I have right here? 5. How many x's do I have there? None. So if you write x, you're wrong. It says no x's. What the shit is that? So let's do this. Let's use this property. What would I have to do? Like, if I had x cubed on the bottom, what would have to be on top so I end up with 0 using the subtraction property?
3.
3 also, right?
Yeah.
Because 3 minus 3 is 0. But what is something divided by itself?
1.
Yeah, so this is also 1. So x to the 0 equals 1. Anything to the 0 power is 1. In fact, another way to see it real quick. X cubed If I divide by x, that becomes x squared. If I divide by x, that becomes x. And if I divide by x, that becomes 1, right? So this is x cubed, x squared, x to the first, so this must be x to the 0. Right? If I keep losing an x, so there's kind of two ways to see that x, something to the 0 power must be 1. Okay. Another, last way. What's always known to be right here?
1.
A 1. So if I have a 1 and no x's, that's just freaking 1, right? Why would I write x to the 0? Just don't even write it. I don't have any x's, so just don't write it. There's 3 ways to see that x to the 0 is 1. I like it. Kick butt. There's a 4th way. Holy shit. No, that's it, I promise. What's the only thing I can multiply by and something stays the same? 1, right? So what is x cubed times x to the 0? What's the property? What do you do with the
3.
powers?
3.
Add them.
Add them.
So what just happened? I multiplied something by something and it stayed the same, therefore this must be 1. Because the only thing I can multiply by, and it stays the same, is 1. Okay, that's enough. 4 reasons why. Okay. Is everybody all right?
Yeah.
Okay. Thank you. So, what about negative powers? What about x to the negative 1? What in the world would that mean? Well, let's investigate it the same way we just did. What would I have to, if I have x cubed on the bottom, what would have to be on the top so I'm left with a negative 1? No? Remember, I'm going to subtract these, right? If it's a 3 on the top,
Like a negative 4?
almost
2.
2. What's 2 minus 3?
Minus 1.
Negative 1. There you go. Right? You with me?
Yes.
Yeah.
So using that second property where you divide like bases, you subtract the powers. This is one way I can get negative 1. But look at this. Isn't this x times x on the top? Right?
Yeah.
X squared is
Yeah.
x times x.
Right.
And what's on the bottom?
X times x.
How many x's cancel?
2.
How many are left?
1.
Where?
Bottom.
Bottom. Minus.
So a negative power just means flip. All a negative power means is flip it. Is that right?
Yeah.
So if somebody multiplies 2 more x's to me, I pick up more x's. If somebody multiplies x to the negative 2, watch what happens. So if I got 5 x's multiplied, somebody comes along and gives me x to the negative 2, what's my power now? 3. I lost 2 x's. What's the only other way we could lose 2 x's is if I divided. So look, this negative power means flip. All a negative power means is flip it. Okay. Maybe. Okay. Now, I think I can't believe I brought a billion of these. Oh, I did. Okay, so I'm ready in case anybody else comes. Look on page 2. Let's see, is there any work for you to do? So I just have collected some examples. There will be some work to do in here in a minute. But then you start leading towards scientific notation. So then you can start talking about not just x as a base, but 10 as a base. So what would 10 squared times 10 to the 5th, what would that be?
10 to the 7.
Beautiful.
Good job, Tom.
Do you understand? Here's a mistake my students make. No, Jeff. That is a mistake my students make, is copy the problem wrong. Somebody will tell me this. What did they do?
Add extra 0.
They did 10 times 10. But why does that not make sense? Exponents keep track of how many of these I eventually need to multiply. So I'm not multiplying them yet. And what I normally say is 2 10s, 5 10s. How do you get 7 100s from that? I don't see 7 100s. So I'm not multiplying anything. I'm keeping track of how many multiplications I eventually have to do, right? Does that make sense? Okay. So, let's talk about scientific notation itself. What does scientific notation mean? Like, give me an example of something that's in scientific notation.
1.5
Yes?
times 10 to the fifth, for example.
11. Cool, right? That's scientific notation. A number between 1 and 10, roughly, 1 and 9.99, times 10 to a power. Okay. So why does it work like that? I mean, does anyone know what that actually represents? What number that is?
Which one?
This?
This represents.
How many 10s am I multiplying by?
5.
5. What happens when I multiply something by 10? Doesn't the decimal just move once over? So how many times would the decimal move over?
5 times.
5 times. So that's why the shortcut is just move it 1, 2, 3, 4, 5. Because I'm literally doing what this says. It's not just notation, it's a little problem.
When you move right, that's positive. When you move left.
Yes, so I always think, I don't think left and right, because I still have problems with left and right. Somebody's giving me directions, this is true, I have to drive like this, go left, okay, then L, I go this way, right? Got too much other crap in my head. So I always think positive makes it big, negative power makes it small. So sure, you can think left and right, but I always thought big and small, because left and right always confused me.
Positive make it big, this way.
Yes, because I really want this to make sense. So let me come back a little. I just wanted to see what you guys already kind of knew. Let's build up to this, and I'll show you why negative makes it small. Real quick. Isn't this 4 times a million?
Right.
And isn't a million how many 10s? 1, 2, 3, 4, 5, 6. I mean, that's literally all scientific notation is. I know I keep saying literally. I literally don't care. Because it's literally what it is. So that's why the shortcut just becomes find the decimal and count until you have a single digit.
That's 1 through 10.
Yes, 1 through 9.999, right?
The decimal.
So the way I look at it is, this is going to sound strange. I see it as a 10 vampire. It sucks all the 10s out of something. So if I stopped too early, if I stopped here, 1, 2, 3, 4, 5, doesn't this still have a 10 in it? It's literally, I got to stop saying literally. It's something today. I never say the word literally. It's 4T, 4 10s, right? So there's still a 10 in it. So that's why you want to keep going until you get all the way to 1 digit.
4.
Yeah, so 4.0 if you want to. And of course, Sig Figs will come in later. Don't worry. Sig Figs we'll get to. All right, we won't worry about it right now. Yeah. So what about if I had something like this? Does anyone know what that is as a fraction? What place is that in? Do you guys know? What place is this? Tenths,
10.
hundredths, thousandths,
This,
10 thousandths, 100 thousandths. Watch this. 1, 2, 3, 4, 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5 zeros.
Oh,
That's the
why
shortcut.
Why we go 5?
Say it.
5.
Yeah, 5
Not
times we move
4.
the decimal to the end of 4, so there's 5 zeros.
Or you start counting it from which 0?
From where it is. There's the decimal.
Oh, okay.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
I thought you stop in front of the 4, not behind the 4.
Say again?
I thought you would stop in front of the 4, not behind the 4.
If you stop in front of the 4, then it's point 4. You want a nice whole number up there. Yeah. Okay. What does this have to do with scientific notation? Does that look like scientific notation?
No.
No. But how many 10s are this? We already said 1, 2, 3, 4, 5. Isn't that 10 to the 5th? Yes.
Right.
Right. And I don't see any negative powers. But if the 10 would have been up top, it must have been to a negative power because that's why it would have flipped underneath. So if I force this dude, does he like it down here? Is he happy? Yes, he's positive. I'm going to shove him up top. No, he's not liking it. I mean, you can look at it like that, right? It's negative. If it's negative where it is, you put it on the other side. Now it's happy. Silly, but who cares, right? So a negative power does mean flip. So it means I am dividing 4 by 10 5 times. And that's why a negative power ends up making it small. If you're better with the left and right, you can think of it that way. I just think make it small, which means move it that way, whatever that way is. Okay. Maybe? Is that better? A little bit? Alright, so you guys try, let me finally shut up for a little bit.
If there is comma, if there is numbers, what we will do?
How do you mean? Sorry.
Like if there's, like example, 6, 5, comma, 3, 2, 0, like this one, yeah.
So like this, maybe this.
Mm.
Yeah. So what is that in scientific notation? Well, where's the decimal right now?
6.5.
Yeah, so it's gonna be there, so 3, 6, 9, 10, yes? So it'll be 6.521 times 10 to the 10th, right?
Okay.
That's all, yeah. And of course, significant figures come into this, right, eventually.
Technically, the decimal is like behind the zero, right?
Yeah, a whole number, the decimal's always right at the end. It's ready to do this if you need it to, right? Yeah. That's why you don't even write it, because we just know it's there. Okay. Coolness. So you guys, page 3. Do you see where it says 1.4 exercise problems?
Yes.
Okay, try those. Does everybody see that? So it starts with 31,536,000. Right, so write those in scientific notation. Good work. Oops, I did this out of order.
Number 3, I don't know how to solve it.
Let's see.
So for 3 and 4, we just add the negative and do it the same way.
Yeah, the negative does nothing. It just
Okay.
comes for the ride. The answer will be negative, but it doesn't change anything we think about. Good. Ever get the sign in?
No, I mean not.
Put your name, your class, and your instructor.
I'll write it, I'll write for us.
Okay, thank you. My name should already be on there, but I just need to write the class.
Oh, okay.
Okay, this guy?
3.1536.
3.15 times
10 to the
10.7.
3.1536 times 10 to the 7. Second. So you start here, you gotta go back 3, 6, 7. So you get behind a single digit, right?
And we write all the numbers because I write only 3.1.
Yeah, nothing in the problem said round. There's no information about how many Sig Figs, sorry. In math, we use Sig Figs, and you guys use Sig Figs, right? Okay. Significant digits in mathematics. significant figures in science, it's just silly, but oh well. Right, you have to be different. Is everybody cool with that? I knew it was gonna be a positive exponent, why?
Because we're moving from left.
Okay, or it's just a big ass number. So if it's a big number, positive power. It's a small number, negative power. Yeah, because to make a big number, I gotta multiply by tens. To make a small number, I gotta divide by tens. So this guy's gonna come out to a negative power. And now I think I got all the zeros. So it's 2, 4, 6, 8. Is that right?
Right.
6.542 times 10 to the what?
Negative 8.
Somebody wrote this. What would you tell them?
No, it's
No.
it's smaller.
Yeah, because this would make it multiply, it would get bigger. That would make it actually, those 8 tens would go underneath and make it divide, make it small.
Okay, can you explain this because I get it wrong?
What's the matter?
4.2 times 10.1. This is, I just move this to here.
Oh, no.
No.
So, okay. What's the first digit you run into that's not a 0? This one.
6.
If you take it back here, if you do this, so you got times 10 to the what?
Minus 10?
Yeah, you got 1, 2, 3. Minus 11 you should have, right?
Right.
Yeah, right? So, technically this is not wrong, but isn't that 654? Doesn't it have tens in it? You know you're wrong if your answer has more than one digit in front of the decimal. Right? Does that make sense?
Yeah.
Your decimal has to have a single digit in front of it. That's why this is okay. So the decimal has a single digit in front of it. Okay, I like it. And then this guy seems really silly.
This guy is 3. No, it's negative 3.
Yeah, negative 3.2134,
Two.
right?
2.
Times 10 to the.
2.
How you do this? Well, because I don't know how to do it.
Well, okay,
Two.
so every time, it's the same. Wherever the decimal is, you want to move it until it's got one digit in front of it. Decimal's currently here. I want it there, so it would have one digit once, twice. Negative 3.2134, right? So now it's there, times 10. And why is that positive?
It's a whole number.
Because it was bigger than 10, right? It's bigger. It's not, yeah, it's not decimal. Yeah. Okay, maybe. So it's the same every time. Believe it or not, every time it's the same. So,
What about why it's positive? It's not minus?
say again?
Why, where do you put the minus? Where do you put it?
It's here.
Oh,
Yeah.
okay.
The number is negative. So negative number is equal to negative, and so you don't even have to consider this. You just kind of bring it for the ride, right? So how would this problem have changed if there would have been a negative sign? I would have just put a negative sign. That's it. That's all it would have done. Yeah. This changes to a sign notation, and it just would have happened to have been negative. Yeah. Okay. So the negative sign does nothing to my work. It's just a negative number. And then here, decimal's currently here. It needs to be where?
Behind the 2.
Behind the 2. So there's only one digit in front of it. 1, 2, 3, 4. Times 10 to the what kind of 4? Negative 4.
Oh, 1, 2, 3, 4.
Right? Did I cover that all right?
Negative 4, right?
4, yes. Negative 4, yeah. So again, me, I would just say it's really small, so it's a negative number. It's really big, so it's a positive number. You can think left and right if you want to. You guys okay?
Yes.
Get a few people looking at me like this.
Can you repeat what it is gonna be negative 4 and in the number 3 it is still positive 2?
Because this number is bigger than 10.
Oh, okay.
So it's got more, it's multiplied to become that, right? This number is smaller than 10, you gotta divide it to become that, yes.
What would it be if you rounded the number 4?
round it to what?
I guess.
Do you see that? Just, if I just said round this, it is rounded.
Uh-huh.
It was rounded. It was rounded to this place,
Uh-huh.
right? But so if I said round this to the tenths place in scientific notation,
2.4.
it would be negative 2.4 because the next number is a 7. Yeah.
Uh-huh.
Okay.
Okay.
I like it. But of course, either that as we told you, or it's got to be Sig Fig consideration, right? Sig Figs will tell you where you got to round to to make it have the right number of Sig Figs. Okay. How are we doing so far?
Better.
Okay. So then you get how do, well, one thing is, what kind of calculators do you guys have?
We don't.
Do you have any calculators? I mean, what do you use? Do you use calculators?
One class
So you
we,
got you got oh, look at you. Is it like a standard thing? The pink is a standard issue?
Oh, Target.
That's awesome. So you guys have like a standard scientific calculator, not like that crazy Mamma Jamma graphic calculator. So real quick, on the scientific, I will give this back eventually. Oh shoot, maybe this won't be real quick. Every room is different, hold on. Can't do that until it's on. Just want to show you. Okay, slowly it wakes up. So if you have a graphing calculator, I can show you that. Does anyone use a graphing calculator? No, okay. That actually makes me really happy. You might have different opinion. So on a scientific calculator.
do you wanna turn
Oh, sure. I got it. I got you. That's what I do all the time in my classes. I need to hire a cameraman. Let me see if this is what I think it is. Yes. See this little EE? Right? E! That means times 10 to the. Believe it or not. So if I do 7 E2, 7 E2, that's 7 times 10 squared. What would that be? 7 times 10 to the second. What should that be? 10 squared is
100.
times 7.
700.
700. See it? My lighting's bad, but oh well. Right? So the little EE is scientific notation. Now, what I'm really curious about, let me stress
And
this
why
out.
you push the
Sorry?
second?
Say again?
Second?
Just because. I just want to give an example. So
Okay.
that would be 7 times 10 squared. So this little EE button is your times 10 to the, yes?
Mine's just doing -1. Like after the 7E.
Let me see. Oh, you have to hit. Oh, see how it's above that? So you have to hit the second 7. It's like a shift.
Oh, okay.
Yeah. So a little second button is like a shift button. That's how you get to the stuff that's above the buttons. Because the EE is above the button. Now watch this. Let me do something crazy. 9999999 times 9999999. Okay. So I did 99999 times 99999, and I got this crazy thing. Let me see if I can make this better. That makes it worse. It's got to be a sweet spot somewhere. Let me see. Can you guys see at the end what it's doing?
16.
Yeah, so that means times 10 to the 16th. I think it even has a times 10 there. Does it? Let me see if you can help me see. No, okay. Yes, so the EE button is your times 10 to the button, and if you put big ass numbers in there, it's going to do the best it can. It might spit scientific notation back at you, which is then. Okay. Is that all right? Yes. Okay. Okay. Thank you. Oh, I'm trying to give it away. Now, what about if I have a problem that's got scientific notation stuff that I have to multiply and such? So, for example, What if I had 4.1 times 10 to the negative 11 times 2 times 10 to the 30th? Oops. Oh, good thing. How do you do that? Crazy stuff. Oh, shoot. That's not what I want to do. Yeah, that's what I want to do. All right, so real quick, watch on the side here. What is 3x squared times 2x to the 5th? What is this?
6x to the 7th.
Yeah, 3 times 2. 6.
X to the 7th.
And then 2x is 5 more x is 7. Yeah, right? So you put your numbers together, and then you put your bases with powers together. So look here. 4.1 times 2. 8.2. Right? Twice 4 is 8, twice 0.1 is 0.2. Times 10 to the
19.
Yes. You add them, but that's negative, right? So negative 11 plus 30 is 19. That's what's left over. It's kind of nice, right? So if you put in scientific notation, you can have the little number part to worry about, and then you just put your tens powers together. Right? So what about this? 0.0000056 divided by, what do you got, Chef? 280000. Yeah.
So we put
Put
it
it in scientific notation. Scientific notation. What's the top become? 2, 3, 4, 5, 6, 7, right? 10 to the what? Negative 7. I like it. And the bottom becomes 3, 4, 5. Yes. Now, can anybody tease out what 5.6 divided by 2.8 is? What's 56 divided by 28?
To 2.
Yes. 2 28s makes 56. So that's 2. And what do you do with the powers here?
Subtract. So you get negative 2.
Well, no. What's negative 7 minus 5?
Oh,
If I owe you 7 and I owe you 5,
negative 12.
I wish I only owe 2, but I owe freaking 12. Damn. I wish debt calculations didn't understand math. That'd be awesome. 2 negatives make a positive with like debts. That would be amazing. Debt, gone. Yay. It doesn't work that way. Damn. Yes.
But 5.6, why is it -7 if we make the number bigger?
No. If the number is small, the power will be negative because how do I take 5.6 and make it small? I divide by 10. And when these 7 tens go down, and so it would divide by 10. So if the number is small, the power will be negative. If the number is big, the power will be positive. Is that cool? Yes.
So you put the decimal places over, and then divide it by 56 by 28.
Yes.
And that's what you got 2.
Yes.
Okay.
Yes. I don't know if you guys are really cool with that. 5.6 divided by 2.8 is 56 divided by 28. They're the same. It's that thing we did earlier with moving the decimal. And I knew that was 2, right? And then, of course, this you just use rules of powers.
Did you just add the -7 and the 5?
If they were sitting next to each other, right? If they were next to each other, what's the property? You add the powers, right?
Right.
What do you do when you divide? You subtract.
Subtract.
Yeah, but
So it's like -7.
why it's -12?
Huh? Yeah. What's -7 minus 5?
Oh,
Yeah.
is that -5? Why it's minus?
No. It's a 5.
Okay, got you.
But it's on the bottom.
I got you.
Yeah. So I subtract.
Yeah,
Yes.
yeah, yeah.
Okay. I lied.
So addition, or since multiplication, you add.
Yes. In fact, a long time ago, I was tutoring somebody who was on the cheerleading thing, and she was like, multiply, you add. So, right, you make an X, that's multiply. You're like that, that's plus. That's all I remember from whatever the whole thing was. But yeah, when you multiply, you add the powers. When you multiply like bases, add the powers. When you divide like bases, you subtract. Right? When I multiply, I'm getting more of it, and when I divide, I'm losing some of it. Okay. I like it. So, in the interest of time, page 4. Try out number 1, 3, and 4. Yeah. If you want to do the other ones, you can. The answer's in the back, but do 1, 3, and 4 first. The people playing along in the future, watching this recording, here's the problems. People of the future.
Also, can you give us examples how we multiply with the decimal?
How you multiply with decimals.
Yeah.
What are we doing now? Sorry.
Sure, yeah.
We paid what?
On page 4.
Paid for?
Yeah.
Sorry, yeah, page 4, 1, 3, and 4, yeah. By the way, I'm not trying to make my handwriting terrible for you, it just is. My handwriting's terrible, so it's just the way it is.
Three is hard.
Should put more room there, sorry. Let's see, does another marker not work? No, not too good. Should be better. Let's see.
Okay. I don't know. Someone.
So for 3, we have to convert both numbers.
Yes,
to
so this
scientific
one, you
notation.
did the same thing we did earlier. Make them both scientific notation first. I think in the answer key, I actually used Sig Figs, if I remember correctly. But let's not worry about that quite yet. We haven't talked about it. I did that just in case you look at it later, and we would have talked about Sig Figs, so there. And that's why I have like this, right? Just to throw some nifty Sig Figs stuff happening. I'll do the first step on this problem to make sure everybody's on the right track. Oh, you're just not gonna work, are you, blue? Okay, I got one color, great. 1 times 10 to the 6. This will be 2.3 times 10 to the 4. Technically, it should be 0, 0, but we're not too worried about that.
Okay, we go to the right side.
Say again? Is this small or big?
Hmm?
Are you asking, like, why is that negative or something? Or? No, you're
No,
trying to
because
start.
I see the
I think there's
0
no
on the right
point.
side, and I thought we go this way.
Oh, 3. Why did I say 4? Yeah, 1, 2, 3.
I think is that number 3? They have 0. It's 0.22, yes.
0.00. Yeah. I just put a 0 up
Okay.
front. Yeah, we do
So
this
1,
little
2,
0,
3.
dude, so we
So
don't
it's a
lose
3, yeah.
2.3 times 10 and negative 3.
Negative 3.
And this one we go to right to left. Yeah.
Alright, so this one's relatively nice because one of the numbers is 1.
So it's 2.3.
Yeah, 2.3. Let's go ahead and do this one. 2.3 times 10 to the
3. 3.
6 minus 3?
3.
3. Okay. Come back up here. What's 2.12 times 2?
4.24.
24.
Yeah.
4 times 10 to 8.
Yeah.
Can you show me the multiply for the?
Okay, sure.
Thank you.
2.12 times 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 2 is 4. 1, 2. 1, 2. Bam. So real quick, since we're on this topic, if I had to do 0.0078 times 0.3, right? So 4, carry the 2, 21, 23, right? Yes? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the last
Why
step,
it's 5? 1, 2, 3, 4, 5.
yeah, 5 total decimal places, right? So your answer has to have 5 decimal places. I like it.
Mhm.
I like it a lot. Now, if I had time, I would show you something like 0.1 times 0.02. Isn't that 1/10? Yes? 1/10 is in the tenths place. And isn't that 2 hundredths? Yes? Not plus, Jeff, times. Isn't 1 times 2 2? Isn't 10 times 100 1,000? Yes? So 2 thousandths is tenths, hundredths, thousandths. 1, 2, 3. 1, 2, 3. So that's why we do that. We're collecting all of the powers of 10 when we count all of the total decimal places.
Like when I do the multiply, I ignore the
Yeah, at first you ignore all the other
and
decimal
then I
crap.
count.
And
for
then you
both.
count at the end, there's 4 here, 5 here, so there has to be 5 total in the end. Yes. I like it.
Question.
Oh, sorry.
Can you do number 2? I don't think it's up there.
Yeah, we'll do 2 in a second. Let's do number 4 real quick.
Okay.
3 divided by 2?
1.5.
1.5. 10 to the?
Negative 10.
No.
6.
6.
No.
Why?
What do you do with the powers?
Oh, it's
It's 8. What do you do with the powers when you divide?
Subtract.
Subtract. 8 minus negative 2.
6.
8
Yes.
minus negative 2 is 8 plus 2.
10.
10.
Tricky.
Here's another way to look at it. What does the negative power mean? What's the 4-letter word starts with F you can say in mixed company? It's my own little joke, sorry. There you go, somebody got it. What does the negative power mean? It means flip. 4-letter word starts with F. So this would flip up. So now there's 2 more 10s coming. So of course there's 10 of them at the end, right? But when you divide, don't you subtract powers? And when you subtract a negative, doesn't that become plus? Yes? Right? No? Yes? Maybe? Right. Is that cool? I think of subtracting a negative as forgiving debt. Right? And that's why it ends up adding to your stuff.
If you write it out like 8 minus
Yeah.
minus 2.
Minus negative 2.
Yeah.
Yes.
And then you just want to make
Yeah.
And then negative times negative is?
Positive.
So 8 plus 2 is 10. Yeah.
That's how I thought.
Okay. I like it. Somebody requested number 2. What does number 2 look like?
In parentheses, 6.0 times 10 to the second, close parentheses, and parentheses again, 6.0 times 10 to the third, and close parentheses,
Okay. What's 6 times 6?
36,
36. And what's 10 squared times 10 cubed?
10 to the fifth.
Good. And what's wrong with this answer? This answer is wrong.
No decimal.
It's not scientific notation, right? So just move this back one more time.
We add
That should
like
go up by 1, right?
6.
Wait, what?
Or, here's another way to look at it. All right, right times 10 to the 5th over there. That's over there, right?
Yeah.
36. Change it into scientific notation. 3.6 times 10 to the what?
6.
No,
1.
1.
Oh.
So then, yeah, what do you get? 10 to the 1st and 10 to the 5th is 10 to the 6th.
So it's 6.
Yeah.
Okay.
Another way to think about it is, doesn't that want to make the decimal go 5 times that way?
Yeah.
If I move it back 1, doesn't it have to go 6 times that way now? That's the way I do it, actually. I do it less mathematically. I just think about it walking. It has to go 5 steps over, and I go, and it's, oh shit, now I gotta go 6 steps over, right? But this is a more, mathematical way to do it. Okay. I do this with my students, and I call my hopeful Tai Chi. This is, please, okay. All right, now comes our favorite. Everybody's favorite. I know you guys love Sig Figs. You guys love them, you want more of them.
The units?
Huh?
You mean the units?
Sig Figs,
Okay.
significant
Okay.
figures, sorry, just Sig Figs, right? You guys call them Sig
Yeah.
Figs, right? Okay. How many rules are there? You guys, when you were taught Sig Figs, how many rules were you told about how to calculate how many Sig Figs are in something? Do you guys remember? Did they give you a sheet of things, and it was like if the 0 is here, you count it. If it's not, you don't count it.
Yeah,
No?
we got something like that. I just can't, I just
Yeah.
remember like, not, if there's a 0 between non-zeros, that's.
All right, let's
significant.
let all that go.
Yeah.
Just let it go. Watch this. You ready? Okay. So there's only two situations. It's either a whole number or it's a decimal number. Right? You with me? If it's a whole number, like for example, that. Any whole number, the number of Sig Figs, you start at the first non-zero and you stop at the last non-zero. That's it. What's the first non-zero number?
4.
4. 1, 2, 3, 4, stop. There's 4 Sig Figs. Right? So in your rules, it would talk about that 0 is not important. Screw that shit. Just don't count it. Right? So if it's a whole number, I think of it as book ends. Start at the first non-zero, end at the last non-zero. Any whole number. That's how you do it. So what about, so this would be 4 Sig Figs. What about, what you got, John? 1 0 1 0 0 2 1 3 0 0 0 0 0 0. How many Sig Figs?
You stop at 3.
8.
Yep, that's right. So you start here. 1 2 3 4 5 6 7 8. 8 Sig Figs. Because that's the last non-zero, right? And why did I count them? Because I'm not done counting yet. You just count everything. See, you don't have to worry about, is the 0 important? What about the 0?
So
Yes?
Start at the first whole number. and then
Start at the first non-zero number,
First non-zero.
end at the last non-zero number.
Okay.
So if I would have put a 3 here, don't I pick up a lot more Sig Figs? Okay,
So start at the first.
first non-zero,
First non-zero, last non-zero.
first non-zero, end at the last non-zero.
Okay.
So what about if it's, I'm sorry, this one had 8 Sig Figs. By the way, why do we even have Sig Figs? Why do we even have that existing? Why is that important? Did they tell you? They didn't tell you, they said, do this shit. And nobody was like, why do we do that shit? I always get those students, why do we do that shit? I'm like, great, let me tell you, right? All right, here's why they're important. Let's say one team A goes to the Antarctic and they measure some ice sample and they measure something and they get some amount of gas in the ice sample and they get 0.03. That's pretty good, right? That's right. And then team B comes along, those freaking show-offs, and they measure something and they get that. Now mathematically, are those different numbers?
Yeah.
Try again. Mathematically,
Oh.
are they different? No. Real quick. What is this as a fraction? 3/10. What is this as a fraction? 1, 2, 3, tens, hundreds, thousands, 30 over 1,000. Doesn't that reduce to 3 over 100?
Yeah.
They're the same number, yes? So math looks at this and goes, okay, what the shit's wrong with this? Science, whatever, right? Science people say, and now tell me, what's your gut tell you? Which team was more certain about what they measured? Which team had the balls to go out further, right? This team was more certain. Because they went all the way out to this place. So it's sort of like this. It's not exactly like this, but it's sort of like this. Are you guys okay?
Yeah.
It's sort of like these guys think it's anywhere from 0.025 to 0.035. Right? 0.03 is right in the middle of those. So they think it's somewhere in there. These guys think it's anywhere from 0.0295 to 0.0305. Isn't this much tighter? Right? If I go more and more decimal places, I'm showing people I know better what this is. Couldn't this be 0.025 and still be this? No? I don't know. All right, maybe it's a little bit like that. Okay. So if that's why it's important. How many Sig Figs does this have? Oh, we haven't talked about it yet. Damn. Right. Sorry, I think I want to make decimals. Let's talk about decimals now. Now we got motivation talking about decimals. So if I have decimal numbers, you start at the first non-zero and you go all the way to the end. Start. This is all written in the packet. I'm not going to write it again. Sorry. Find the first non-zero number and count all the way to the end. So over here, Where's the first non-zero number? There. And it's at the end. So how many sig figs?
1.
1. This one. Where's the first non-zero number? There.
3.
Count to the end. 1, 2. 2 sig figs. So their findings are twice as significant. Sort of, right? It's not exactly right, but they are more certain about what they measured. So that's why science does that. It's a very quick way to communicate. It's the same number, but it communicates a lot of stuff to somebody just by putting the number. So if one team gave me this and another team gave me this, holy shit. What were you using to measure? That is crazy, right? And these guys are like, yeah, we did our best. I'm trying to measure and it's all shaky and I'm cold. All right, sorry. Maybe? Does that make any sense? So that's something you should always feel free to ask. Why did you guys invent this? And if your teacher can't answer you, then you go, okay, well, they have to be able to tell you. That's such a fundamental thing, right? It comes up all the damn time, yes? So they better tell you why it's so important. Okay, so does that make?
So it's just to be more precise.
It's a way to communicate how certain you are about your findings. So I could write a whole paragraph about how, or I could just put another zero and say, I'm sure out to this place. Well, I'm sure out to this place. Right? Some kind of weird game show. I could be certain out to this place, right? So it's, no. Okay, maybe. Okay. So decimal numbers. So like, what about this? 1024.9000. Ooh. How many sig figs? It's a decimal. So what's the only real difference? You start at the first non-zero in both cases. If it's a whole number, you end at the last non-zero. If it's a decimal, you go to the end. So how many sig figs? 8. Good. 8 sig figs. Because they could have written it like this, yes? And that would have communicated less certainty. But if they go this, they're like, okay, I'm certain out to this far. I'm certain out to that far. That means a higher sig fig. Maybe? That's the 2 rules. That's it. Did I say anything about when a zero is important? No. Maybe. I guess all right.
So it'd be 8 significant.
Yeah, this will be 8 sig figs.
And if the zeros weren't there, it'd just be 2.5.
Yes, if these zeros weren't there, it'd be 5. Now watch this. If the decimal wasn't there at all, so if it was 1024900, how many sig figs now?
5.
5, because you start at the first and at the last, right? So the only thing you remember you've been sure. The only thing you need to remember is if it's a decimal number, you count to the end. If it isn't, you stop at the last non-zero. You don't count to the end. Right?
And 0.04, how is equal 40?
Wait, what now?
So
0.04.
What's
How does it
equal?
equal 40? It doesn't. What do you mean?
I
If I
think
use
that's the
different units,
composition
maybe.
Units.
Like metric, you use different metric units?
Yeah.
Maybe.
That's possible. So listen, 36 inches is how many feet? How many inches in a foot?
12.
12. So 36 inches would be how many feet? Every 12 inches is a foot, yes? So 36 inches would be
3 feet.
3 feet. Does 36 equal 3? 36 does not equal 3, but 36 inches equals 3 feet all
Yeah.
day. Okay. So 0.04 does not equal 40 ever in the
Yeah.
universe. 0.04 somethings does equal 40 somethings, right? If it's correct. So we'll talk about metric in a minute. Yes.
So if it's decimal, you count to the end. If it's a whole number, you stop at 0.
Stop at the last non-zero.
Oh,
Yes.
okay.
So let's try this. If you guys get this will be quick. Page 6. No, I'm sorry. Page. No, it's where's the ones? Where have they gone? There they are. I'm sorry. Yeah. Page 6 at the top. They're high. Do all 6. If you get the idea, those should be quick. If you don't know, that should also be pretty quick. Is he still going? Hopefully he's got enough battery. Poor little dude.
for example, this has 8. You go right or left?
Here?
Hmm?
Right or left, how do you mean? So as we read, yeah, so, what did Professor say? So I think it's more important, your question is more important if I had a whole number. So start here, 1, 2, 3. There's no more non-zero numbers, so there's 3 sig figs, right? I mean, here, technically, it doesn't matter which side you start, to be honest.
And why this is 8?
Because these mean something. So I have to count them. So if somebody said 1024.9, they're less certain about what they measured than these guys. These guys are more certain.
Mm.
Yeah.
You said decimal, you count to the end, no matter what, no matter what, so it's like all that. And then
Yes.
the whole number, you just count, if it was just counting to the whole number, you
Count to the last whole number, yeah.
Yeah.
Last
that too,
non-zero number.
yeah,
Last
non-zero.
non-zero number. The zeros are a whole number, yeah. So real quick, if somebody looked over and then said, oh, there's about 100 people over there. And then the guy next to him said, oh, I think there's about 95 people over there. Who's representing that they're more certain about what they're talking about?
Right there.
Okay. There's about 100 people over there. And somebody else goes, there's about 95. There's 95 people over there. Right? Who's representing as if they know more precisely how many people are over there? The person saying 95, yes, no. If I just say, oh man, there's about 3,000 people over there, right? And somebody else says, there's about 2,580 people over there. What would you say to that 2,580 person? You would say, did you go count? What? How do you know that precisely? So sure enough, 3,000 has how many sig figs? 1. 2,580 has 3. It's a communication of how certain I am about what I'm measuring, right?
Can you write that down, for like the numbers that you just said? Just
Sure.
I know that's just an example.
So, somebody says 3,000 people over there, and somebody else says 2,580, I think I said, or 2,850, whatever it is.
Yeah.
So he has 1 sig fig. This guy has 3.
3, yes.
Stop at the last non-zero, yeah. Yeah, like it. Yes.
We get a lot of questions in our class that's like, oh, round to the nearest significant figure.
Yes, we'll get there.
Okay.
That's what we're about to get into. How do you do calculations? So real quick, what about these? Number 1, 3 sig figs, I love it. It's a decimal, so you know to go all the way to the end. Number 2, 4. They're both the same number, 1 and 2, but that one is more certain. They're both decimal, so I count to the end. 3.
4.
6.
Intriguing. It's a decimal, so what's the
7.
first non-zero number?
1.
1. Then you count to the end.
4.
1, 2, 3, 4. If I wrote that, real quick, if I wrote this in scientific notation, oops, what would it look like? 1, 2, 3, right?
2
3.
Negative 3, right? Can't you see better? That has 4 sig figs. Right? These are what your teachers focus on a little too much. They're just placeholders. Their only job is to tell you how important that 1 is. Is it 1/10? Is it 1,000? Is it 100th? Is it what is? Right, so they don't count in the sig fig calculation. And if you make it scientific notation, then it's even more clear, right? Now, real quick, on the same idea, what if this person did go count and got exactly 3,000 freaking people? And he wrote 3,000. Somebody's like, oh, you're not sure. Your sig fig is 1. You guys with me so far? Isn't that kind of mean? Isn't that evil? I mean, this guy knows. You with me? It's like, I freaking can't. I did like they do with the tires. I put a little mark on them arm when I counted. I marked you. Mark you. Right? You with me? So, one way this person could communicate that is make this into scientific notation, but leave these in. Right? 1, 2, 3. How many sig figs here?
4.
4, right? It's a decimal now, isn't it? So converting something into scientific notation actually makes the sig figs much easier to see. Okay, maybe. And again, I mean, how would I make this into scientific notation just directly? Would it just be 2.85?
Right.
Right? 1, 2, 3. Yeah. Okay. Did we finish all these? Number 4.
Would be 3.
Good. It's a whole number. So you stop at the last non-zero. 1, 2, 3. Number 5.
4.
Same idea. Whole number. You stop at the last non-zero.
5?
Sorry.
So what's 5 in the?
5 is 4. Sig Figs. Because you stop at the last
Oh.
non-zero.
Oh my God.
You only count to the end for decimals. So number 6.
6.
6. I love it. Kick ass. What time we got? Oh. Now. Okay, so that's that. Okay. Is that better? Is that the same? It didn't really help?
Better.
No, it helps.
It's still frustrating. I understand.
Yeah.
Much better.
I just need more practice.
I think it's probably better. Because I've seen the rules they give students, and I still don't really understand. If any of you guys are watching, why? Maybe there's a reason. I don't know. There could be a reason. I want to be clear. There could be a reason they do it that way. I'm a math guy. Now, how do you deal with computations that you have to keep track of the Sig Figs? Yes? Oh, yeah. Oh, shit. Okay. So multiplication and division. Let's talk about those. So, for example, if somebody had 1,000 times 0.295. Ooh, this is going to be a nice problem. You with me? So I had 1,000 times 0.295. And neither one of these are conversion numbers. You guys talk about conversion numbers like 12 inches in a foot. 12 doesn't have 2 Sig Figs. Do you guys know how many Sig Figs 12 has? That comes from 12 inches in a foot. Do your teachers tell you that anymore? It has infinite Sig Figs. You can't be any more precise. By definition, there's 12 inches in a foot. So you basically don't consider conversion numbers for Sig Fig considerations, right? You don't even think about them. They don't affect anything because you can't be more precise than them. Is that all right? I mean, they must have addressed that somewhere. Yes?
No.
Oh, you're just right. Okay. So what is it? So the very first level of this is don't just do it. What's 1,000 times 0.295? 295. Now you've got to round it so it has the right number of Sig Figs. And basically, with multiplication and division, it's the weakest link. You want to communicate to people the least certain part of the problem, right? So which one has, how many Sig Figs does this guy have? 1. This guy. 3. Who's the weak link? This guy. So this has to have 1 Sig Fig.
Oh, if you round it up to 2.
Oh, yeah.
Real quick. What is this? What if this is a number of people that are going to come? How many people are going to come, do we think? How many people? How many people right there? How many people? 295. Do not tell me that rounds to 3. Are you going to put 3 chairs out? Let's round that. 3 people are going to come. And then you have 295 people show up and you're like, oh shit. Everybody share? Right? So that always just, I don't understand. So it's got to be something in the hundreds, right? So you need 1 Sig Fig. So you start counting in 1. Okay, so I got to round to this place. I got to round to that place. The next number's a 9, so you make it 300. So that's still about 295, but it's got 1 Sig Fig. So it's doing 2 things.
Why we see to the 9, not to the 5?
Say again. Because again, if I'm rounding to this place, I only consider the number right next to it. Yeah. Okay. So all of these, 290, 291, 292, 293, blah, 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 they would all round up to be 300. All of them. So the next digit doesn't do anything. Yeah. Is that all right so far? That's how division also works. It's the weakest link. So what about 0.0109 divided by 4,200? That's where you need a calculator. I didn't bring any with them, sorry. I just brought my own. So if you don't have one, just maybe somebody help us out. BR calculator. Just tell me the full number that it gives you.
Zero point zero 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 two five nine five.
So 0 point.
0 0 0 0 0 2595.
Okay, I like it.
Mm.
Is that what you guys get? All right. Top has how many sig figs? Nope. Three. Start at the first on 0.
Yeah, 3,
All the way to the end. 3 sig figs. The bottom has
2,
2 sig figs. So the weakest link is that.
2.
So watch this. 1, 2. I went around to that place. Right? Because how would I count sig figs? I would start at the first on 0 and count to the end. So I wanted to go 1, 2. I went around to this place. You guys with me? That's how you just count in until you get to the place, until you make 2 sig figs. If I go bam, bam, that's 2 sig figs. So that would be 0.0000026.
6.
Is that right? 'Cause I did it and I got a different answer.
I don't know. I was just taking what somebody said. What'd you get?
Like 2.59523809.
Sure.
And then
What's it say at the end?
as E.
E what?
Minus 6.
Minus 6. 1, 2, 3, 4, 5, 6.
Oh, okay.
Yep. So yours just gave it in scientific notation.
Okay.
Yeah. I appreciate that. Thank you. Is everybody okay with that? You guys all right? You guys okay?
So
Do you see?
multiplying and dividing, we always want to go with the smallest number.
Smallest sig figs. The weakest sig fig rules. It tells you what your answer has to be in terms of sig figs. Right? And then once you count over for sig figs, that tells you what place to round to. Maybe.
And if that wasn't, let's say that was a 4 next to the 5, we wouldn't round up because it's not.
It would have been
5.
2, 5, yeah.
It has to be 5 and above to round up.
Yes, kick ass. Because 259 is closer to 260 than it is to 250. Okay. So, what about addition subtraction? You guys already know what that is? I want to know what that is.
We can review.
Hmm?
We can review that.
Okay. So, what if I had, so the reason the rule for addition, subtraction can't be the same as multiplication, division is, what if I had 1.0 grams or something, and I add 0.3 grams, right? So that's 1.3 grams, yes? Right? But if I use the rule for multiplication division, that has, well, shoot, I did that wrong. I want that to be that, there. I wanted to have 1 sig fig. Oh, that would still work, Jeff. So that has 2 sig figs, and this has how many? 1. So I'd have to round to 1 sig fig, so then this would still be 1. Do you see a fundamental problem there? I had 1 gram, I added 0.3 grams, and I ended up with 1 gram. Does that make physical sense? Is that cool? It can't be the same rules as this. In fact, how did I line this problem up? If I had 1.0 plus 0.3, how do I line that problem up correctly? All right, here, guys. If I told you to add, let's see, I get something more interesting. 1.297 to 14.31. If you had to do that by hand, how would you line it up?
Line up by decimal?
Yeah, the decimal rules the day, correct? On addition, subtraction. There you go. So for addition, subtraction, the answer has to have the least decimal places any part has. So?
Like, if this has 2 after the decimal
Yeah,
line,
this has 2 decimal places, this has 2, this has 3.
The
So my
answer.
answer needs to be rounded to 2 decimal places.
Can you show?
All right, well, somebody add that for me, just in your calendar. We're not gonna, we could do it by hand, but why wouldn't? So 14, I could do it, 1.297,706.5. Okay. Is that right? Okay. The weakest link was this guy. He's only got 2 decimal places, so the answer has to have 2 decimal places. 1, 2, I went around to this place. So what would I make it? 15.61. There. So multiplying, dividing, it's Sig Figs. Who's the weakest Sig Fig? Adding, subtracting, it's decimal places. What's the weakest, the least number of decimal places? Maybe. Oh, shoot.
And we do added first or subtraction first?
You do them as they come. Right? Order operations. Remember order operations? Please excuse my
Oh, you're not Sally.
dumbass son. That's right. That's my alternate version. Okay. So try on page 7. We don't have much time left, but try on page 7. Let's just try a couple of these. Page 7. Try number, I don't know.
6.
Huh?
6.
Sure. Number 6. Number 4. I'm just gonna do them out of order for whatever. Number, I don't know, let's see, what's a good one? One more, number 8 is a good one, because that always confuses people for some
Yes.
reason.
So for division, the number with the most significant figures is on top.
Sorry?
For division, the number with the most significant figures is on the top.
No, anything could be on the top.
Okay.
Yeah, so I could have a problem like this, divided by 0.1234567.
Mhm.
Right, this has 3 Sig Figs and this has 7.
Mhm.
I mean, or it could have been turned over.
Okay.
So division, I just have to deal with whatever they give me. But the important thing is, the answer to this would have to have 3 Sig Figs.
Okay.
It doesn't matter where that is, it's just whatever the least Sig Figs, wherever that is. Okay. And of course, unfortunately, if you don't have a calculator, I don't want you sitting there doing long division. The whole point is just to do the first part in the calculator and then to get the rest of it. And then you do the rounding. I should have brought my calculators and I just didn't think about it. You want to use this one? I don't know if you know how to use it.
And do we will have time to do the units or
The what now?
units?
Yeah, I think so. That's the last thing we'll do, the units. Yeah, don't worry. I can go a little bit over, and then I gotta get it out. And I'll talk real quick about the last couple things, but they're pretty quick. Yeah, I like this one. What do you guys get when you do 500 divided by? Give me a few. Give me some of the stream. I think it's 100 something.
116.22231.
222.
31.
111. Now, we're dividing. So what rules the day? Nope. When you add, subtract, you have to line the decimal up, and that's what I'm hoping is going to trigger. Oh yeah, when I add, subtract, decimals rule the day. When you multiply, divide, it's Sig Figs. What's the Sig Figs on top is how many?
4.
4, good. 4 Sig Figs up top. On the bottom? 5 Sig Figs. So how many Sig Figs should my answer have?
5.
4.
Weakest link.
A week is 4.
4. 1, 2, 3, 4. I want to round to this place. The next number is 2, so it's just. Yep. I like it. All right, this guy, when you just do it in the calculator, what do you get? 120.
128.879.
128.879.
879.
Okay. Blah blah blah. Or it's just 87. Yeah, there. In this case, it's all subtraction and adding. So if I did line them up, it would be the decimal places that. So there, what rule are they? Who has the least decimal places? He's got 3, right? He's got 2. He's got none. So my answer should have none. So I want to round to this place. I want to have none of this stuff. So it'll be 129. 9.
And I do, like if I put them.
Yes?
This
Yeah,
way.
so it'll be 125 minus 0.23 plus 4.109. And you guys remember filling this in with some zeros? Just to, right? Is that
I
what-
put the 0
just to kind
before
of keep
the
things.
1.
Huh?
Put the 0 this way.
You
before
did you
the
put a
1.
0 where? Here?
125 and the decimal, the 230 under 125.
Uh-oh,
And
that's
this
not
one.
good.
Yeah.
And again, it's like terms. You can only add like terms. Isn't this 2 tenths? I can only add that to another number of tenths. That's why the decimals have to be lined up, so they're like terms.
Doesn't 125 have three significant figures?
No, I added that in. Yeah, it's got, I'm sorry, okay. It's got 3 Sig Figs. I thought for a minute you were gonna say 3 decimals. It's got 3 Sig Figs, great. This is an addition subtraction problem. So what rules the day is decimals. So who has the least decimals? We'll have to take that off. That guy.
Oh,
None.
okay.
And that's why my answer has to have
Okay, yeah,
no
yeah.
decimals. And now this guy, what is 3.3 cubed? Just put it in the calculator, wait.
35.937.
What was it?
35.937.
35.937? Now what is exponents? They're based on what operation? Exponents are based on what operation?
The problem, we cannot use the,
Sorry?
we cannot use the calculator.
Oh, so you'd have to do 3.3 times 3.3 like that? And then get an answer and then multiply by 3.3 again?
Yeah.
That seems unbelievably crazy. You guys are gonna be nurses, right? Or what are you gonna be? CVT?
Yeah.
What are you gonna be, sorry?
CVT.
Really, I suck.
Yeah.
Cardiovascular technology.
Okay. In the field, are you gonna rely on, that's it, all right, they can do what they want to with you, I'm sorry. And I'm sure they have a reason, and I don't mind reinforcing certain things, but this is a little silly, I agree. All right, you have to
Oh
do
yeah, it's not much.
9, 9, 0, 9, 9, right?
27.
9, 8, 1, 0, 8, 9, 1, 2, bam, and then you have to do times 3.3 again. Yeah, look at that. Here. Now again, I don't know if there could be a reason. Now, real quick, we're not done with this. Tell me, so isn't exponents based on multiplication? Right? And when you multiply, what's in control? Decimals or Sig Figs? No, it's only when you add, subtract decimals, right? When you add, subtract, you're gonna line the decimals up. So when you multiply, it's Sig Figs. Now, how many Sig Figs does this have? So the answer better have 2. 1, 2, you wanna round to this place. So what's it become?
36.
36. again, it's just a quick way to communicate to somebody seeing your work how certain you are about what the measurements that went into your work, right? Okay, last thing, and I'm gonna put the YouTube
Yeah.
video, and
Okay.
your teacher will be able to
Thank
tell you.
you.
Yeah, you're welcome.
We'll do units now?
Yes. So, if I want to convert things, so for example, from earlier, 12 inches are in a foot, right? How many feet in a yard? You guys know? How many feet in a yard? 3 feet in a yard? Yes, maybe?
We use the metric.
No, I totally get that.
Yeah, yeah.
Let's just start with the only country on the face of the earth that still uses things based on the King of England's foot size. That's what our freaking, I'm sorry. We had the whole American Revolution and we still use these crazy ass units. If I wanted to convert 78 inches, if I want to convert that to yards, right? One of the most important steps in conversions is to consider your path. People just skip that over. I can go from inches to what?
Feet?
Feet, and then from feet I can go to
Yards.
yards. So I got 78 inches. I don't want inches, do I? I want feet. So where would I put inches so it would cancel? On the bottom, does it make sense?
Mm.
Inches to feet, that cancels. Keep going. Where would I put feet so they cancel? Because I don't want feet.
Bottom?
On the bottom. And now you fill in the numbers. 12 inches in a foot, 3 feet in a yard. And if it's on the bottom, I divide. 78 divided by 12, divided by 3. So help me out. What is 78 divided by 12 divided by 3? 6.5. 3.16. Oh, 2.16. Damn, that was close. What did I do wrong? Oh, well, shoot. That'll do it, John. Yeah, you had to come with 2.16, blah, 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 blah.
Yeah.
And now comes Sig Figs. And that's yards, right? Sig Figs. What's the only number up there that's not a conversion number? Like 12 is a conversion number. 3 is a conversion number, yes?
Yards?
78 is somebody's measurement they made. What did they communicate to me? How many Sig Figs is this? 2. So my answer better have 2 Sig Figs. 1, 2. 2.2 yards. Maybe? See, this thing is crazy. This little grid dude, if you took any chemistry in your entire life, you've seen this bad boy. Moles to freaking grams and Avogadro's number and yes? No? Even if you don't know, then maybe right now you're happy. All right. I'm almost certain all of you taken some kind of chemistry. Metric, real quick, metric. What do you guys know about metric? What's like the biggest one that people normally know is kilo, and then there's stuff above that, of course. But there's kilometer, and then we don't know this one normally, and we don't know this one normally. Let me see. And then there's meter. Now what's the next thing down for meter? Yes. Normally that's not known.
Millimeter?
That's milli, which is 3. That's 1,000th of a meter. So every step is a step of 10. So we normally know centimeter, and what cents mean? How many cents in a dollar?
900.
100, so cents is like 100th of a meter.
Mm.
Milli is actually 1,000. It comes from French, actually, but so millimeter is 1,000th of a meter. So every step, this is, now watch, let me fill in. Here's hectometer. Anybody ever heard of that? Hectometer, decameter, decimeter. So there's deca, hecto. I think I have them in there, do I? I can't remember. Deci, centi, milli. Right? Do I have my King Henry stuff in here? I might not have put it in here. I need to put it in here. I don't have it in here. I need to add that. Okay. That's weird, Jeff. All right. So this is funny because every step, so the metric system is based on our number system, which is based on 10 for some reason. I just don't know why it would be based on 10. If we had 8 fingers, our number system would be based on 8. Trust me, because what's the most natural way to count stuff? Fingers, and then you take shoes off, right? But, so every one of these is 10 of these. Every one of these is 10 of these. So every one of these is 100 of these. You guys get the idea? So watch what that means. This kicks so much ass. If I have 2.17 hectometers, and I want to know how many centimeters that is, how far away is centimeters from hectometers? 1, 2, 3, 4. So I'm going to move the decimal. 1, 2, 3, 4. 21700. Right? Just imagine trying to convert miles to freaking inches or something. I mean, holy crap. But how about, it's even worse for volume. Imagine trying to do teaspoons to gallons. Ah! Whereas every other country on the face of the earth just moves the decimal around. Right? Yeah, maybe.
We have ohm, kilo ohm.
Yeah, so for measuring resistance, you got your ohms, and for measuring whatever, yeah. So the only thing we use in America is liters. We have a 2-liter of Coke or something. That's the only exposure almost to metric depth. And sometimes the tools have 9mm sockets, such, okay. So that's the beautiful thing about, and watch this. So if you just remember these, you can convert in it very easily. And there's a saying, King Henry died Monday drinking chocolate milk. Right? By the way, this works for volume, kiloliters, hectoliters, decaliters, so forth, right? And of course it works for weight, kilograms, hectograms, decagrams, and of course you guys get a lot of milligrams and stuff, right? Okay. Same thing, it's almost too good to believe. We got freaking gallons over here, and then got miles over there, we got pounds over there, and ounces, and yeah, okay. Crazy. That was a little bit rushed there at the end, I'm sorry, but we're basically out of time. Anything desperately needing help? So like 4.0 is algebra review. Normally the algebra you end up doing in these classes is kind of more minimal. There's not like a ton of algebra. And then making a good graph, of course. Making a bad graph is the quickest way to make a science person cry. Math person for that matter too, right? Is there anything else?
You will have other meeting?
Another, yeah, so actually the next one of these workshops, it's this Friday, but it's a next level up. It's like talking about trigonometry for people in physics and such. So there's 2 levels to this, yeah.
Like example.
Huh?
Give me example.
Example?
Yeah, or what type?
Vectors, and how to calculate magnitude and direction of vectors and such. That's for physics. But I've already had plenty of CBT people, cardiovascular technology people come into the Math Study Center for help with just math. I've had chemistry people come in, physics people come in for the math.
Okay.
So if you have something that's basically just math, you can come to the Math Study Center. You with me?
Okay,
What was
and
that?
to solve.
Once it starts to get a little too deep into chemistry or biology or whatever else, we might go, I don't know, but if it's math stuff, we don't care where it's from.
Like conversion problems.
Conversion problems. Come on into the Math Study Center. Yeah.
What building is it in?
It's 7112. It's in the Tech Mall,
Okay.
and it's in room 112.
Okay. Thank you.
Thank you so much.
You're welcome. Thanks for coming out, guys.
Thank you.